Howdy folks, hello and welcome to ASEAN Tech Forum. In today's cloud first world, all the applications, every industry, every enterprise has this rush to deploy their application or migrate their application in the cloud, right? That is the current trend for some time. And when you try to move your application to cloud, you realize that your legacy monolithic application is not best suited for cloud kind of environment, or you cannot take the full advantage of cloud capabilities, right? Um, so what they started doing, they started building or migrating their application to cloud native format. And today, the most prevalent or most popular way to uh, deploy a cloud native application is via container, right? So in my earlier video, I have talked about container a detail in detail all you need to know about container. And if you have not watched that playlist, here's the link, and I'm going to put this link in description. You can go and watch that. So my assumption is you are familiar with container and container orchestration, but we'll still touch base a little bit very quickly on container and container orchestration in this video. All right, so what is the agenda today? Containers, container orchestration. Then we will see, as everybody tried to move their application to cloud and make it cloud native, does this present any kind of security threat or open any loopholes, right? And it is not that industry, regulatory body and academics are not aware of this, right? So that's where there are already some research and recommendations has shown up, and we are going to discuss that a little bit later in the video. Then I'll give you a practical example who are the player in container security area and how their implementation differs. I have one working setup. I'm going to show you the demo, and then we will review the report, the preliminary report which I am getting together in this video. So again, assumption is you are familiar with the Docker. If you're not, I highly recommend you go and watch this video, and I'm sure you will like it. All right, let's go ahead. What is container? Container is not a totally entirely new concept, right? Container has been always part of Linux operating system, because in Linux operating system by default you have resource groups and uh, some default resource group with default allocation. If you take one step further and you restrict your resources in a namespace and allocate a certain resource per application, that make it container, right? So the definition is isolated process. Container is an isolated process, a group of process in an OS. It depends on two concept: C groups, um, limit container resource uses, and namespaces. Isolate containers from each other. Who are the major player in container? Docker. Docker is a company which is very popular in container, and the Linux container. What are the advantage? Host kernel enables system call for each container. Efficiency is the one advantage. Multiple app can share same host OS. And speed. It is quicker to start than a virtual machine, right? Then comes container orchestration. Let's understand what is the need of container orchestration. In containerized application, where it's a microkernel environment, right? The number of container grew really fast. That means in a decent application, you may have thousands of containers. Then you need them. It's your job to manage, deploy, inter-network between container. It's so cumbersome. That's where container orchestration come into picture. Kubernetes is one of the very popular container orchestration developed by Google, later given to CNCF, and now a very large community of developer working on Kubernetes. So let's understand the formal definition. Container orchestration are tools which group systems together to form a cluster where container deployment and management is automated at scale. That's the keyword. Deployment and management of container is automated at scale while meeting below criteria. What are the criteria? These are the cloud capabilities criteria: fault tolerance, on-demand scalability, optimal resource uses, auto discovery to automatically discover and communicate with each other. That means uh, zero networking or less networking, right? This is all automated. Accessibility from outside world and seamless update and rollbacks. So these are the cloud native applications advantage which you get when your application is on cloud, and a container orchestration should meet this requirement while managing containers at scale. All right. So let's go to the next topic in the agenda, review the NIST recommendations. To review NIST recommendation, this is the paper you should be looking for. NIST Special Publication 800-190 Application Container Security Guide, right? So um, NIST has done a very good job, a detailed study of container application and what you need to secure, what you need to look for when you deploy your application on cloud in form of container, right? So we are not going to read the whole paper just because we respecting everybody's time, but I highly recommend you to download and read this paper. And if you want to get an idea what NIST is recommending, you can look at the table of content. So NIST is basically touching all the component of the applications, right? When you deploy your application in terms of Kubernetes cluster or container, so it is touching each and every component and recommending some security practices like image creation. So all the container image has been created. This was a bad idea to click that. Okay. So it talks about image, how you store an image, how you import an image, and all those things, how you set up your registry. Uh, then the container risk vulnerability within runtime software, host OS risk, right? You have a host OS which is shared with multiple application. So what is there any risk of shared kernel? Is there a risk of larger attack surface, right? Then counter measure to major risk. So what you can do to countermeasure those risks, how you can secure your image, how you can secure your registry, how you can secure your orchestration. Everything is, there are certain recommendation, host OS, countermeasure, and all those things. One of the other article I found from the company called Aqua, they have condensed this paper and basically presented in more consumable format. And, and now you can see it's a like 20 page compared to 63 page. We'll talk about Aqua in later, but same paper 800-190 written with a little bit condensed. So here you can see it is actually talking about all the things what NIST is recommending. Image risk, what are your image risk, right? For container images, what is the registry risk from where you pull your images, then what is the orchestration risk, container risk, and the landscape, right? How the application is pushed from dev, test, and production lifecycle. Okay, what are the threat landscape can be there. Okay, just to save some time, I'm not going to in much detail. I'll leave it for viewers to read it through. Right, host OS risk, and then it's presenting a very nice checklist. Okay, so if you are deploying your application, you can refer to this checklist, that is my application supporting all these countermeasures or the best practices, right? Lately it says that how what is the Aqua's method to find vulnerabilities, but till page 5, I think if you read till page 5, you'll get a very good idea how your application, container-based application, can be put to a threat and how you can secure it. All right, let's talk about players in the industry. In North America, I found two companies which are very good at container security: Sysdig and Aqua. Aqua is one I use in my demo. If you want, apart from NIST paper, if you're really interested in container, want to know more about container and especially container security, the book which I can recommend is Container Security: Fundamental Technology Concept That Product Containerized Application, written by Les Rice. This is one fantastic book and I highly recommend it. This is written in very simple language. Okay. I believe Liz later started working with Aqua. I may be wrong, but Aqua Security is one very easy to get started tool with for your container security, right? So that's what I use. Let's go. Let's Let me walk you through the demo. What you need for demo. So I use my GCP or Google Cloud Platform account to make this test bed. So basically, I went to GCP and used their Kubernetes cluster, which you sample lab, which you can just create very quickly, click, 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 and get some written documentation, and you can have your Kubernetes cluster up and running. To integrate Aqua, what you need definitely a sign up with them in account with Aqua. Once you have the account with Aqua, you need to integrate Aqua with your Kubernetes project. And this is where you can see under service account, I have my Aqua, which is using API with a secure key. They are integrated here. So I'm giving Aqua some permissions to my application. You may say that that may be another threat, but you have to trust your supply chain or your partners, right? So this is how you can integrate. Once you integrate, you can set a certain frequency, how frequent you want to uh, scan your applications or your container cluster. By default, it's scan every 24 hour and present the report in this format. Okay, let's go to the report. AquaWeb security report, scan sometime back. This is my cloud account, assessment date, scan summary, green, orange, red, and gray. Severity count, same, deep red, light red, or orange. So like that, right? Scan overview, the complete report overview here, low, high, medium, I think. So it is actually scanning everything. You can see it says VPC network, and I didn't do any custom changes in GCP lab. I just deployed sample GCP lab. So this report actually helped me uncover that the sample lab may have certain vulnerabilities, right? So when you are deploying your application to cloud, don't trust the default setting. And that's where this kind of scan comes really handy, right? So everything in green looks good, and that's where you can see I don't have any problem here. But yes, hi, open SSH. This is what I did. I said that anyone can access using port 22. So that's the high risk. But that's the error I made myself, right? Because I was just lazy. I just thought, okay, let's open all zero port 22. Then internet file system is fine, FTP, everything is fine. You can see I'm just gonna scroll down slowly so that you can have a moment to read the report and see. Right now it's checking how we can come to container from outside world like telnet, VNC client, VNC server, all those kind of popular applications. Okay, Kubernetes private endpoints. Okay, compute OS login enabled. So this is a medium risk. I want to look some high risk, right? Kubernetes network policy enabled. Okay, what is it? I don't know, but at least this scan is giving me some idea that hey, you need to look into it, right? Network policy enabled, pod security policy enables. Okay, that makes sense. And I am so it is actually not just monitoring the application, but entire hosting of application, your VPC, your RBAC, that is IAM services, then the different container application and how they talk to each other. So everything is scanned in very granular detail, right? VPC network open salt. Okay, this is critical. So looks like there are some security issues with the password. Maybe it's not salted. Um, this description, now it's a detailed report. So if you don't understand what does that mean, here we have a description also, right? Some additional info and recommendation action. So you can see open DNS, determine if TCP or UDP port 53 is open to public, right? And it says that TCP and some known IP. Awesome. So only application can make DNS query, not anyone else. That's the strength, right? Recommendation is it's providing you recommendation also. Restrict TCP port 22 to the known IP addresses. So determine if UDP port 445 is CSP open to public. Let's see internet file system to known IP addresses. So this is the thing. I didn't change the CISF. I didn't do anything with FTP. It came by default. So that means cloud has certain default rule which are not very secure and present vulnerabilities. Kubernetes scan, container scan, this kind of container scan can help you fill the gaps. I highly advocate you have some type of, if not Aqua, not 6 day, because this is no promotion, or maybe some in-house solution, but always make sure that your cloud and your container application, they are secure enough, uh, because ransomware and cyber attacks are prevalent, and we a tech user, we need to make sure that we have security first in our mind, and it's embedded in all our application or the work we do every day in technology. So this is what I wanted to show you. I'm not intended to post this report anywhere, but if user want, if I see many users are asking for it, I may decided to publish it on my GitHub page. So do let me know. And please let me know what you think about Kubernetes or container security. If you have any concerns, suggestions, do let me know in the comment section. And I'll say you can go ahead and like and subscribe the channel, because that help this channel to grow and reach many people, so that it can benefit everyone. So thank you for watching. Thank you.